What was it?
Out of syllabus.
Out of service?
Syllabus, out of topic.
Oh, out of topic, out of syllabus.
Any questions on out of topic? You can always raise a question, right? During the exam, saying this out of
Oh yeah, you can always raise a question. Okay, so let's finish up this stuff here so we can conclude a few concepts. I'm going to briefly show you this one. This is lecture number 15. It is on time sharing, yes? No, there's nothing on the threads. So just because there isn't doesn't mean you don't want to listen to me.
That's what I told her.
All right. So, well, I should say, maybe I should just lie to you and tell you this is all on the exam. Time sharing operating systems. All modern operating systems are capable of sharing processes. So this is kind of, okay, so today's lectures are sort of recapping. So there is some relevant concepts. Because what I'm talking about is concluding a lot of the concepts I started talking about in day number 1. The first one I started talking about on day number 1 was the fact that each app runs in its own process. And the processes don't talk to each other, which is actually kind of important. So if you go back to lecture number 1 and you start thinking about how this is an operating system, by the way, and you're writing an app that's working on it, that's running in a JVM. It's not all running on the same JVM or DVM. It's all running on its separate instances of it. So nothing is being shared. So that's why we have the threads, and that's why threads come into place, because then we can have multiple processes running together. So if you think about the process and the concept, we can have process scheduling algorithms that work inside of each one of the programs. So between multiple users and multiple processes, there's a lot of, or hundreds of different processes running usually. Many are managed by the system, some are managed by the user who's executed them. So we do have a time sharing environment. In fact, your app can actually have an intent that starts a broadcast receiver, starts a background service, which is nothing more than a background process. So from a process thread perspective, that is actually on the exam. We have services that run as background processes. Do you have to create one in Java as a thread? No, you can actually use the Android feature of the service and create a service and use it as a service in terms of the concept. So threads versus processes. A process in general is typically defined as the execution of a single program. This is actually on the exam, actually. I'm not kidding about that, because this gets into the services concept. If you think about it, there's a couple questions on services that are specifically related to threads and processes. So the process is typically defined as the execution of a single program on the computing device. Processes are scheduled by the operating system, and the owner of the operating system is root. And so the manifest actually is the one who's keeping track of the process. So the relationship also discovered, I'm just waiting for these guys to stop talking. Hello in the back. Thank you. All right, so otherwise I just start yelling. Now I even lost my train of thought. Here we go. So the manifest, which is also on the exam, the role of the manifest is like, I keep calling it the traffic guard, but what it's doing is just the process manager. It's deciding which process can run, which is why we have to register intent. So we have our intent filters that are controlled by the manifest. So every single activity that you're going to run during that process of the main running process of the app has to be registered with the manifest. So if you have multiple activities and you're going to send an intent back and forth, if you don't put the intents in there, you don't put the activities in the manifest, it's not going to run, because the manifest is being your, and for lack of better words, operating system traffic guard. It's acting as the security manager for the definitely for the application. The other thing is also another thing important to note is in the manifest we set the permissions. So there's definitely a couple questions on the concept of the manifest. What's in the manifest? What's being used by the manifest? So as a prime example here, all the intent filters are registered, all the intents are registered, all the activities are registered. The name of the application is in the manifest. So are all the permissions. Can it use the internet? Can it use GPS? All of those things are also in the manifest file. So the process has a long lifetime to it, like a web server, short lifetime to it, one run of a short program. Processes don't share memory between each other. Processes on the Android do not share memory between each other. Most operators support inter-process communication. We have to get that through intents and through other ways of sharing data. On the Android system, we don't have inter-process communication going on. We don't have that for security reasons. We do have that within one process. We can have multiple threads running, which is what we just saw a few minutes ago with the thread libraries. So processes versus thread. A thread is a component of a process. An activity is a thread. Those are all started in the form of threads. So we have named threads, services, activities. Those are all running within the same process, which is how we get multiple things to run simultaneously. Usually considered the smallest unit that can be scheduled by an operating system, can share memory and instructions with other threads in the same process. Most operating systems support inter-process communication. For our time-sharing operating systems on a single processor computer, we can have a round-robining one. I'm not going to get into all of the different. If you take an operating systems course, you'll learn. Actually, I think I'm teaching an operating systems course next term. So we get into process synchronization, the different multi-CPU scheduling, processes running, and round-robin, and all the different ways that we can schedule and look at stuff. Slow Android apps. So slow to Android. By default on Android, all work is done in a single thread, the main application thread. This is why we looked at threads today. Threads and multi-threaded programs. That's how you make the slow Android app faster. By default, everything runs in a single process, or aka thread. So if a component of the work takes too long, the rest of the work just sits there, just waits. And what's going to wait? The UI, because the UI doesn't talk to background processes. It just sits there. Only one thread at a time is running at any one moment of time. That's a problem. So we use multiple threads so we don't block. As an example, for a long time, to access data across networks, preventing respawning of any GUI events or anything of that nature. In an Android OS, if the GUI doesn't respond to an input event in less than 5 seconds, then it is considered unresponsive, and the operating system will actually kill it as well. So you can have a beautiful running program that is just a little slow, and the operating system will just kill it for you. That happens with the maps, believe it or not. Why does that happen? Because you have a slow GPS connection. There's a problem with your GPS. There's a problem with your internet. You loaded up this beautiful map thing, and it's just taking too long to load. If it's within the threshold, it's going to have this lovely little timeout message show up. The whole thing's going to bomb out on you, and you'll never see the map. Well, unless you have a really fast internet connection, a really fast GPS speed, and everything's running correctly. Depending upon how much you got loaded on that sucker, you may not necessarily see it. It happens all the time, actually, with commercial products that you download. It's not just with your apps that you're building. So Android thread design. Only perform your GUI action on the main application thread. Don't perform GUI actions on non-main application. Spawn separate threads to perform data intense or slow actions. So you spawn the thread, you leave the GUI alone, so then you synchronize them. So make these threads asynchronous. So the first main thread does not have to wait for the check on the other threads. And instead those threads run as they need to report back to the original thread. So they're worker bee threads. So any changes made to the UI should go through the UI threads. Do you need to do that for any particular app? No. This is why we saved this for the last weekend. There's a lot of people who don't know that they can actually create multiple threads. And then they have these really ugly, poor, and I shouldn't say ugly, they're just very non-responsive apps. You sit there and go, why didn't I just thread that off? Why am I sitting here waiting for this app to do something? You usually see it with internet and mapping apps actually. So threads, we just went through this morning, so I don't necessarily need to run it. The only point I do want to reiterate is that we have the runnable implementation, if you remember, that basically implements runnable. So if you see that in a question, you see that in an app, you know it's using a thread. It's the only thing, there's 3 different ways of doing it. I'm not going to ask you to nitpick details about runnables and thread programming. The concept of the process, the thread, is on the exam. However, the programming aspect of it is not. The stuff we covered this morning is not on there. But you should know that we have multi-processing, multi-threading capabilities, although the programmer has to do it. And by default, each app runs in a separate process of its own, and there's only one process, not multiple. Instead, we have threads that run inside of the process. So it's a multi-threaded process that's being scheduled by the Android system. So a thread can belong to a thread group, as we saw before in the examples this morning. A group is related to threads. And then we have implement runnable, and we initiate calling start method. So runnables, the object implements a run method. We saw that this morning. That's pretty much it. So we'll employ the examples in anonymous on the fly. Runnable code. I can skip this. We already saw it this morning. In fact, if you look at the example I showed you this morning, you'll see even a little bit more. It was using a counter instead of a tick, but it's just a thread that starts up that clicks and clicks and clicks and, you know, ticks and ticks or counts or whatever. So we can see the thread's actually working. Handlers. So notice I was writing a long output here, not the GUI. It was actually going out to a system out. In fact, you'll see this is very similar to the example that's out there actually. GUI components are not considered thread safe. So manipulation of 2 or more threads concurrently can cause an underlying data to become incorrectly managed, as I mentioned before. So we can put a handler on there and associate each thread with a handler. And the handler will detect thread conflicts and detect non-synchronized events and corrupted data associated with each one of the thread's activities then when it's allocated. And it's simpler to administer the assistance of it to receive messages, send messages, can schedule activities. So other threads can post runnable code. So typical use of the handler, create a handler for the main GUI thread. So the handler that you get with the on-click methods, those are thread handlers. How are they thread handlers? From receivers, from sensors. We're going to go through some sensors in a few minutes on the phone that we haven't looked at yet. So we have some things that broadcast messages. As an example, to shake the phone, to turn the phone upside down, to touch the phone. Those are all different things that come through the concept of a handler. We have receivers that handle the messages. It's kind of like try and catch. We try something and then we catch it. Well, when we put a listener or an observer, like a listener on something, it's in the form of a handler. It handles what happens when the event actually occurs. Well, then we have an on-click method, or we have a this method, on rotate, on whatever kind of thing that comes out of it. Same concept. We can put this on the threads too. So we can put a handler on the thread activity that says, we've been trying something in the background. It's been going and trying to download this file, but I can't do it. We'll put a handler on there so we don't have to interrupt the GUI. The handler will just report back to the GUI and say, hey, you know what, it's timing out. It's timing out, but we can be doing something else in the foreground, if that makes any sense. So you can create a handler for the main GUI thread, create a thread for some intensive background work that might be going on, employ the runnable method on that, implementing that interface. And so when that background thread is done with its work, it can post a second runnable to the main GUI handler. So it comes back through the handler indicating that an update request to be performed on the GUI. Comes back and say, hey, I got the message, I got the information that you wanted. What do you want me to do with it? Here it is. And so that's how we're going to use a handler to communicate between the main active GUI and the background threads that might be running. So the actual second runnable received then runs by the main thread. So ensuring that only one thread is changing the GUI at a time. We don't want multiple threads. It's not thread safe. So GUIs aren't thread safe because anyone who wants to can access and update it. When it means it's not thread safe, it means that the multiple threads can cause corruption to the GUI because it's changing the GUI. The last thing you want is an app that is going, what in the world is that doing? It's going to be flickering. You see a flickering app, you see an app that buttons go away and come back. It means it has multiple threads reading and writing to it, and it's not very safe. It's got some inconsistencies with what's going on. One person's putting the button there, one person's taking it away. I see this with web apps all the time, actually, with, you know, like for bulletin board postings and stuff, and all of a sudden, what happened? I thought I was logged in. Now I'm not logged in anymore. Oh, and then you put something up there and it shows up twice, or you know, the little box shows up and you press send and nothing happens. You press send again and you have it like 5 times now because there was a little delay. We have a multi-threaded kind of internet application going on, and the GUI's not safe. It's not thread safe. So here's some code that freezes from a handler, and this is from an on-click listener that's being used. with an on-click event for a button that's going to be updating it. You have a thread that's going to be a GUI handler created for the thread. And the code still freezes. That's the button, and the GUI is counting. Yeah. I was trying to actually demonstrate that earlier, and I got the button to freeze momentarily. It's if you go through the thread example I was showing you earlier, the first one, it's not synchronized, it will freeze. So the GUI freezes up, is what the problem is, because it can't run the threads. It's already running, and it hasn't. The running thread hasn't returned yet, and so it's frozen until the thread comes back. Okay, so that was number 15. This one is a continuation of what we looked at. I'm going to kind of skip through this because we don't necessarily need it. It's going along the same lines as the app that we built this morning, or looked at this morning, with the runnable and the asynchronous. So the parameterized runnable example, just showing you what's in this lecture just in case you want to come back and look at it yourself. The async task. So Android supports a fairly simple mechanism, specifies and hides the process of working directly with threads. The methods that are built in automatically to make an asynchronous versus a synchronous. So just as we have a synchronize and synchronization that we can add to make things work together, we can also make them work in a serial fashion. One thread's going to run, and the next one's going to run, the next one's going to run after that. So one extends the async class and implements several different methods. Do in background, do progress update, do post, do pre-execute. These are all things that are actually done one after another, and the code itself demonstrates this from the project this morning. So conceptually straightforward, very systematic, but challenging because you have to put it together so everything looks like it's happening all at one time, although it's happening one after another. So it's basically taking a bunch of threads and making them serial instead of synchronized, which is basically what we're looking at here. I'm not going to go through this because we don't necessarily need this for the exam, and people are now just focused on what do I need for the exam. Oh. But this is more, if you're interested in some of the details associated with the implementation of the example, this is definitely going to provide you a little bit more background information. There we go. I know, burning through it. We're going to go a little slower through this one though. Alright, so we saw databases. We spent a good couple of examples on databases, and we know how to create one, we know how to select information, and we know how to query one. And we know the concept of the cursor. This is all testable material that's on the exam as well. So the database returns the cursor, if you remember this right. We read right to the cursor. What's the cursor? It's the temp information that comes back with the results set normally, or a yes or a no, a Boolean kind of, it ran, it didn't run. Essentially an iterator over the return values, so we can actually come through, and there's no SQL statements actually, there's no SQL questions on the exam, but there are some database questions. And there is one related to the cursor. So we have the get next, get previous methods that we can use with the cursor to iterate through the result set that we get back as a review here. In terms of creating the database, we can select the information using a query, and in the query function that takes on the parameters. And remember, we had those queries that we ran when we went over the database example. Review that, and you'll see all of the, like 5 or 6, well here I got 1, 2, 3, 4, 10 or 11 things that we put parameters that we're putting in that method call. Just sort it. The ones we're not using, or just search it to, I don't know, put it in different, to apply different things to it. The ones we don't use, we put null in there, so the statements. In fact, review the database stuff. That's probably a better way of refreshing your memory on that concept. Besides the 2 parameters, anything else can be left. We need to know what we're going to search on. So we need to know the string name of the table that we're going to query. We need to know what we want out of the query. Most of the stuff, however, can be left to null. We can limit the number of rows that we get back in the results set, stuff like that. The where clause is how we strategically define what we want to get. So in terms of creating a database and selecting the information from the cursor has the ability to scroll back and forth through the return values, ask about states of the cursor in the results, access data in the results, get the count, get the column name. Remembering all those methods that we can run on the cursor that we get back. So we actually create a cursor, we ask the cursor, what's in there? We run the methods on the cursor that's coming back. The cursor is the result of the query that we're running. Here's an example to refresh your memory. Cursor return values is going to be mealsdatabase.query. And we're going to run from the meals database. That's really all we need is just those two. Run this, return the values, and then we can return the value to get column index, get column name, all sorts of different things that we can get back out of there. And we're really not going back and forth with the database. We're using the query to find the information that we got back as the result set. So we can select information. This is the same example we did actually with the meals example. And we got this far actually, and we saw this live with an example. We ran two databases actually. One with a database helper, if you remember, and then the other one that just ran queries without the helper. So refresh your notes on that. And this is on the same theme, actually. In fact, we started this part of the lecture as well, so this is sort of review. So looking at here, we have other database commands that we can look at. We can update the rows. We can create a context view. We can stuff with the columns we want to update, and we can just run a query to update it with the where clause. And there's an update function as well. Deleting a row, we can also do that. So anything that you can do from a DDL or a DMS, a DDL or a data definition or manipulation, a DML command, you can run through the database query methods. So you can do a query dot execute, figure out an update that you can perform on a particular query by calling an update function. Deleting rows to remove it, meals database.delete meals, and think of it more like you don't actually have to run the query, you're running a method that's running the query. Depending upon the type of query that you're running, it's going to be an update query, a select query, a delete query that you're going to be running. Don't have to know the syntax for it, however. Just the concept of using the cursor, concept of being able to iterate through the cursor, what the cursor is doing in concept, the concept of there being a database. And the database is SQLite, if you remember. It is not something the user installs, it's on the phone itself. It's actually part of the features of the Android operating system. So you essentially are using a feature. So most database functions are just abstractions or parts of the SQL language, which is the big picture of it. Yeah?
Like when we have an application developed in SQL, like we load it to our mobile, and when the database sizes keep growing with the information, so it will start consuming it.
It consumes a lot of resources. In fact, if you don't delete that database, you'll have all of the phone memory taken up. It doesn't use the SD card, which is kind of ironic, but you can. And actually, there's other methods, which I'm going to get into in a few minutes, that can make your app run a little bit faster. So when you're running the database, it's stored in a file that's stored with the application in the memory of the phone. So when the application loads up, it loads up the database. If the database is huge, it can can totally ruin the performance of the app. And it can go to the point where it runs out of app space. So each app is only allowed a certain percentage of space, so you can actually exceed that. And then you're going to get, low memory messages that are going to run from the phone. So if you've ever seen one of those, out of memory or getting close to memory or memory usage, something or other, sometimes the database itself won't even load at that point. So there's other choices that you can do. Did I answer your question or no? Okay. So there's other choices that you can do. You can save data on the phone without using the database. So just in case you didn't hear or didn't catch what the question was a few minutes ago, it was a question concerning the size of that database. Large databases used with applications make the application run slow. Don't necessarily want to use a database, although databases are easy to use. They come in handy for a lot of different things. Sometimes they lend themselves to a natural solution for the app design, but there's a con to that. Obviously, every time the database is updated, you have to put a method in there to update the data that's in the database. You have to create the database, remove the database when the app is no longer being used, yada yada. Run slow. If you just have a couple pieces of information you want to store, there's other ways of doing it. You can put it into a file, or you can use a shared preference, or you can use the content provider. So why do you want to keep a database of telephone numbers and addresses when you have something that does it for you automatically? So a lot of people would opt for the content provider instead of the database. So database is only one way of storing and accessing information on the phone. We're going to look at two other ones here that make a little bit more sense with smaller approaches to it, which make it run faster. May actually be overkill for small or non-complex data. Alternatives exist. We have shared preferences. And we also have files in the Android file system that we can use. So usually you'll see this on the SD card. Easy way of telling is go out and look at your SD card. And you'll see the application name or some folder that was created. And you'll see a bunch of files. And why are there all these files here? Because it runs faster. They put something on the SD card. Your SD card's always in there, right? So you open and you shut the application, it goes out to the SD card, reads something in, writes something out. What are those going to be? You know, preferences, you know, maybe your username. Think of them like cookies in the old web browser. Very similar to a cookie concept, except for nobody can touch them. Well, let me rephrase that. Theoretically, nobody can touch them. However, if you know where they are, you can touch it, just like a cookie. So it has the same problems as cookies. It's shared in a public area. It's on the SD card. So actually the user can, like, you know, mount their phone up and remove it. And then it's going to cause some malfunctioning of the app, perhaps, depending upon what those were used for. Or better yet, I can read the information. Or I can, it could be another app that just goes, in fact, there are some apps out there that do this. Go to the SD card and find out what you got there. And tell you what's on the SD card. And then, hey, look at this, you got this, hey, look at that. And the app can read the information. Theoretically, the app can turn around and send the information out too, couldn't it? Wouldn't that be kind of like a virus? Kind of like spyware? Kind of like, you know, so it opens up the concept for a little bit more problems, which is why people don't like using files, but you can use shared preferences, which is going to be a little bit more protective. So common notion about apps. Often allows users to set preferences for apps, often only a small number of settings, usually. That should be respective across instantiations of the app, including after killing the app, so you can be stored in memory only. So, for... I'm sorry?
Cache the data.
You can cache data to files. Yeah.
Like we do in the web applications, we cache the data. So
You can do that. Right to a file. Yeah. And usually if the file is going to go away, going back to the file concept, I haven't talked about files yet, but usually you're not going to put anything like the user's password or something like that in a file. But yeah, if you're going to cache data, like how a web browser caches, yeah, often use data, put it in the file. And then if the user removes the file, if it's not in the file, then load it fresh. Then it takes longer. So just basically using it as a cache is perfect. So as a substitute of that, shared preferences are different because they're controlled by the operating system. So for a shuttle tracking app, as an example, allowing users to choose polling rates, how often to query where the bus is, and stuff like that, going back to the bus example that we looked at in the mapping program. You can remember all of those things in a shared preference. So shared preferences are stored in, you guessed it, key value, label value pairs, just like strings. They're stored with the app. They're not stored on the SD card. So they're stored in the resources. So we have another yet resource that we can use. So keys of strings, values that are actual types. So we can set the type of the data that we're storing. Shared preferences will be visible across all components of one app, across activities, classes within the app, and could be made visible to different apps, though not common for the problems I just mentioned. If we're going to use shared preferences, we can just make them available for the particular app that's supposed to be using them, but everybody in the app can do it. In terms of saving data, we can retrieve the shared preferences, request to edit them, store the data using a put XXX kind of thing for the label and the value pair that we're going to do, and then commit the changes. Very similar to a database, but it's not taking up the same overhead of the database. The Databases are a little bit more memory intensive. So we can save data, then we can also retrieve data. So retrieve the shared preferences here across by typing in get. So instead of going put, we go get, and we're going to get a label with a value that's associated with it. So the methods might here maybe for the default value is returned if the value is not associated with the label in a preference. Or default value is important for users who are opening up the app for the first time, or users who have never changed something or never saved preferences. So in terms of saving color of the background, user's name, I don't know, click count or something, whatever kind of information you might be saving, a lot of people will populate the preferences, especially if it's reading it, if it's getting the data, put some default value in there. So you set a default, so if you don't set it, then you don't have to worry about it. The app will still run. Problem with this is, if you put some things to read a preference and it reads the preference, but the preference has never been set. Believe it or not, it's really bad design because really your app's going to crash. So here's an example here of a run counter activity, and it's using a preferences. So the object type is called shared preferences. So it's very similar to the preferences set in an iOS application, except for it can be done a little bit easier in this context. It's not in a preferences file, it's in a resource file that's in the XML format. So shared preferences versus the onCreate bundle. Because we have the onCreate bundle, which is actually more of a cache. So we have the bundle, if you remember from the life cycle, we can open up the bundle. We have the saved bundle from the super that we're running on the onCreate. We're using this bundle concept, which is like a cache of information that's floating around. So we have preferences that we can store that are going to be loaded into the bundle, and we can use that to restore session information. Well, it's actually not session, but same concept actually. So how's the difference from the bundle that is passed on the onCreate and the onSaved instance methods? And how could or should we make use of the shared preferences in the City app or any app similar to it? Well, which is actually kind of interesting. It's very similar in concept. The only problem is that, or the only difference is that shared preferences can be updated and saved. To answer these questions for you, the onCreate, the bundle itself, if we kill it, we have no bundle. It goes away. So preferences keep it persistent. So it falls into the persistent category. The bundle that we get from the different stages will disappear eventually. It's part of the life cycle. So if the app is paused, great, we have it. But if the app gets killed, we shut the phone off, we turn the phone back on or something, we're going to miss it. So direct file I/O. So Android also provides a hook into the Android file system, as I mentioned before. So these are part of the resources. So shared preferences is a resource that we're going to use with a key value lookup. In the direct file I/O concept, we're reading and writing to files, text files. And this is more of the cookie concept, as I mentioned originally. Not as safe, because the shared preferences, although we can share among apps, we're not going to. We can have the ability to block it off completely. Any app who wants to can go out and look at a file, as long as if the file is stored on a shared piece of information, like the SD card as an example. So the methods for opening and closing input and output in the methods do not allow folder specification, typically employ an app-specific permission. So the permissions are set on the app, can employ with general Java I/O classes and methods. So if you are taking the Java I/O class, and we looked at a Notepad application actually in our second weekend, if you're taking this class simultaneously, we saw file I/O. Believe it or not, it's identical. Just like the threads are identical, this Java is Java. File I/O is the same too. So you could actually, well, one of the assignments actually is a tutorial for Notepad. It's using Java I/O the same way. It's a Notepad as a Notepad. It works the same way in Java as it does on an Android app, actually. So Java has two different styles of I/O, streamed and writers. We have the byte type, or we have the text type. Often we can wrap more complex streamers and writers around simple ones. So each acts as a bridge between the higher level and the lower level of the abstraction and bit manipulation. So Android and Java I/O text output. Common wrappers using Android open file output. So we have some Android APIs that wrap around the Java APIs that allow us to automate the opening and the closing and the reading and writing to files. So it gives back to the file output stream. So we have print writer, new print writer, buffer writer. That should look familiar to the people in the Java class, actually. It's the same thing we did with the Notepad examples. Works the same way. So it just is a way we can print writer, we can do text output here with use a print or print line method to write arbitrary strings of text, automatically called toString on objects. Then we have the buffer writer, output writer. So don't necessarily have to know this for the final exam. Just know that you have the ability to read and write to files. If it's available in Java, it's available on the Android. It's Java programming, just like the Java threads are the same way as well. But it goes a little bit above and beyond the scope of the course, actually, to get into writing and reading and writing to files, because we did this in the Java class. If you did it in Java class, you did it in Android class. It's the same thing. So the files appear in are stored in a file called data. So in the file structure itself, if we look at the file explorer, which is another interesting thing I didn't show you, but I actually kind of showed you by default when I was looking for the emulator controller. It was the file explorer. File explorer actually shows you all of the files that are inside of the running app as we run it. And you can see there's one in there called data, which is where your files are going to be stored. You can also open up the SD card and do what's called external data. Internal data is going to be inside of the inside of the app space as running it, but in the file explorer I think I have to load up an app to see it. This is the same window that's in the slide here that's going to be showing you all of the running information that is stored on the device, theoretically, for the app that's running. So in here you'll have files that are going to be inside of usually inside of a data folder, so your application files, file name, and then you have data. So you can use the DDMS to move files on and off the device as well, which is kind of interesting. We haven't done this one, don't necessarily need to do this one, but just the same, we actually did this in the iOS class if you're in that class, but we got the preferences file on. We just loaded it up in a different format. We actually loaded it up into a project, and then we loaded the project into the emulator. Here you actually load it onto the emulator, into the emulator space that you can actually get to from the file explorer. This is from the running app, so I have to run the app an app in order to see it running. So.
This seems to be Unix box.
I'm sorry?
This seems to be Unix box.
Did you know that the Android is based on Unix?
So I mean we can have access to that.
Yeah.
And we can play around the backend also.
Let me run an app, and I'll show you what I'm talking about. Actually, I know that the threaded one works. Let me just my emulator. This will work. Actually, will work on the emulator as well as the VirtualBox emulator as well as the other ones. So let me just run this guy. I'll show you what I'm talking about. I believe it should communicate with my emulator, but we'll just see what happens. And in order to see a file list, I actually have to have something running because it's speaking with the emulator. But while this is loading, I'll kind of finish on the concept here. So if you go in the DDMS and you click on the File Explorer, you'll see all of the files that are associated with the running app that's running, given the path for it. So we'll see what happens when I load the multitask. But let's just leave that up for a second. Maybe this is loading. Ah, good. That was quick. So let me connect the two of them. Now we're communicating. So let me just run it. I don't necessarily even need to have it running. I just need to start the process running. It's probably enough at that point. There we go. So this is, let's see what we've got going on here. Data, backups. Make this column a little bit bigger so I can sort of see what's going on here. These are from all the crashes and miscellaneous Bluetooth. Don't have very much on here actually. But this is, if you click on the emulator over here on the left-hand side, the emulator that you're running, and click on the File Explorer, you should be able to surf the contents of what of what we're able to communicate with. What is D? D is. You can actually get to it if you're interested. In fact, I know you mentioned. Let me kill this actually for a second. You can actually get into a terminal emulator on your. You can do this on the built-in emulators as well by going into terminal out here. It is a Unix box.
Yeah, makes sense.
The device. This is an emulator
This
of
is
an
the
Android
device,
device.
because this is the device
You can do
which
it on
is-
here too, on the real device.
This is a device where the operating system
Yeah.
is running, which is mounted on Unix server. Right?
Yep.
That's our mention. But why is there on the IDE? I mean,
What do you mean?
like on the Eclipse. So,
This is just communicating with the emulator. It's showing me the file system that's on the emulator. This is
On
the
the
file
emulator.
system on the
on the
emulator.
Okay.
That's why I said I had to load something up on the emulator in order for this guy to connect to it. This is just all the crap that's on my emulator. And I'm like looking at this going, what's D? I probably did some testing thing. I created D. So, but here's my SD card. But I don't have an SD card in here. But in my SBin, actually, don't really have any commands. Or I have AD. Well, this is my SBin for my emulator that's set up to the ADB manager actually. So, but long story short, you can drag stuff on here that will make it work with the app that's running through the emulator. So the communication is essentially able to go back and forth. So I can take a file, put it in the data directory out here, load it up so it's accessible by the running app on the emulator, which is a way of simulating it. So
I mean, basically using this, I can have one device connected once. I can get the copy of one device.
Yeah.
And copy to another device.
yeah. Yeah, actually, you can take the apps that are installed on this device and load it into another.
That's really good.
That's why people like Android. Well, one of the reasons why it's an it's an open source and it's Linux based. So, I mean, this looks like a. Here's the D. So here's that D. So you can see it right here. Actually, I'm like, why do I have a directory called D? So I'm going to remove -RD. Read only. So I have to make it. I have to change it, mount it in a non-read only. So by default, it's mounted read only. But somewhere along the lines, I created D. I don't know what's in D. Nothing's in D. Oh, is it really? Okay. Well, thank you. How did you find that? Googled it?
No, actually, it shows the information on
Oh, okay.
system kernel and device.
Where are you seeing that in the Eclipse?
In the information side, in file explorer.
Oh, okay. 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 Yeah. We have D in here too? No. Okay, so anyway, that was the point, was to show you that you can get at the file system through the emulator controller. Well, it's not the emulator controller, it's through the Eclipse tools that are going to allow you to connect to that. But you're just looking at a Unix box, so you can drag and drop through the Eclipse system, and you can put files on the emulator that way, or to emulate the use of the file in terms of the concept. So. Moving right along. File and I/O network I/O. So reading and writing to network locations and files. As I mentioned before, we have direct file I/O. So Android file hooks into the Android file system we just looked at. Methods for opening files, input and output for files. Methods that don't allow folder specification, typically employed by application-specific permission. So we're giving permission to external data. If we're going to use folder specification, we have to do it on an SD card. So it's easy to kind of open and close files and write it to the card. However, there's no security there at all. So you can employ with general Java I/O classes and methods. And so in terms of this, we have this information here. This is kind of a review of what we just went over a few minutes ago. So I'm going to kind of go through here and look at web data at the beginning. Accessing general web data. So we've seen in the previous slide how to access web services, essentially calling a method. On another machine detailing how it's hidden from the programmer, we're just basically going to call the URL, create a URL, get a file, send a file. And we had a couple projects actually that downloaded images from a URL. So if you just want to access HTML data, there's easier ways of doing it. Maybe you can grab a menu data or something like that, or pick menu app. So accessing general data, direct HTTP access, which we've seen actually in a couple of different examples, very commonly done. And the API supports it. One approach might be the URL connection. So when we create the URL connection, this is the method that we used to, I think we had one that downloaded a picture. We had another one that used a URL connection to send and receive information across the network. So specifying a URL, we can request the connection to that URL. We actually did this in the Java class too. It's done the same way as it's done on the Android. So you treat the open connection as an input stream. So we've already done it with files. So and then we open up an input stream, we send and receive, and then we close the connection, essentially. So because it's network-based, it requires a try and a catch to deal with potential errors. So here's an example of the URL connection. So we specify a URL. URL is going to be the data URL is going to be equal to a new URL, and we give it an address. And then we use it as an input or output stream. So then we can run methods. In this particular case, we called the URL data URL. So we have .open, .close, read, write. And then we can also use a buffered reader in this particular case. So we actually did this in the Java class when we were writing Notepad application. And you'll do something very similar to this to other things on the Android. Java is Java is Java. It's all the same code. So, in terms of processing the data itself, the approach above will also allow line at a time via the buffer reader. So we can read it line by line, word by word, file by file, I guess, in terms of the concept. If you open this and you put this into an Android app, it's a text box. It's going to go to a URL, read some data, and put it into the text field, text view, which is kind of simple. It's one app that you can put on an on-click method for a button. Put a button in there, it'll go out. You have to make sure the data is out there when you do it. So this will basically try on a URL connection that you have to set, essentially. That will open up the connection, create a buffer reader, take the buffer reader, apply it to the input stream reader that's going to be on the open connection to get the input stream. Then take it while there is nothing left, do something with it, write it to a string, store it to a buffer, and then put it onto the text field. So, and then clean up and close the file. So this is a web spider as an example in terms of what it's doing, which is actually kind of easy to do. You think about it. You just go out, read some stuff, put it into a text box. So we've actually done this before. We've seen this done in a couple of the web examples we put together earlier on, a couple weekends ago. Actually, it may have been done in the first weekend of the class. Serial connection here for the output stream or the post. It's done the same way, but we're going the opposite direction. So it's possible to use the URL connection stream as an output stream as well as an input stream. Supports the post component of the HTTP protocol. So the data is sent to a server where it's then competing web forms or to put something into complete a web form to do something with it. So this method is done a lot with PHP actually to accumulate some data, send it out, post to a server, and then have something happen with that on the server. Yeah. It's a great way of sending data back and forth. You don't need to use JSON for that actually. You can use HTTP. Yeah. I'm sorry? You can use it with XML all the time. Actually, it's very commonly done with XML. So, because it's just data, you're just going to send an XML form, you're going to send something, some text, update a server with it. So, no higher level APIs are being used or needed for that. So, it's just the URL connection that's being used for that, which again is a little easier in the Android environment because it's open source. You can just use the connection for it. Okay, menus. Switching topics again. So I gave you some menu stuff. Options menu. Remember now the default project has an options menu support on it. So we have the on create, then we have on options menu create, or I can't remember what it's called, but it's something very similar to that. A little method that's automatically created for you. There's a hardware button on the Android phone and on the tablets themselves. You press the button, it opens up the menu, exposes the activity-specific menus. So these are activity-specific. Menus can hold up to 6 menu items in a tiled fashion, and then you can have sub-items. So, or 5 items and a more button. The more buttons are going to take you to more items, a longer list. So this is an expanded menu. So it's hooked into a button on the screen. And the menus can be triggered by submenus, which are floating dialogues. They look much like drop-down lists. And here's some examples here. So we have, this is the regular old menu, and then we have this list, drop-down list of menu items that we can create. So this is a sample application of similar to the, actually it's the same web view, map view application that was continued in a previous example where the user taps on items on the map, and then so it tells them the distance between one and another or something of that nature. But this is being controlled by the menu. So we had a menu item example, and I believe we still have a tutorial left, but I'll save it for tomorrow because I believe we still have a menus item tutorial left. Layouts, no, it's down in here. No, we have a notification one and a content. I think we did the content provider already. We may have done it already. We had an options menu. I think we've done the options menu as well. Yeah, actually it did. It had colors, red, yellow, and green, and it changed the background color. So we did the options menu already. So in terms of generating the menus for the meta ideas that are associated with it consists of one or more menu items. So the items themselves and a primary 6-option maximum. And then we have the expandable menu, the submenus that don't support icons, but do support checkboxes and radio buttons. So I think we put icons or something, or text on the colors that we put on the menus. We can add menu items that can be associated with the keyboards and shortcuts. So we did an example actually that did this already. So in terms of handling the selection of events, we can put together a listener, so activities are already designed to be listened to by the menu. And so when the buttons are presses, we can just write the functions that are associated with it. And the primary response mechanism is in the on option selected handler. See the one we did with the colors. And that will be a good review if you're looking for a refresher on the menu concept. One function can handle any type of many types of menu presses as well. You can also associate with each one of the menu items some sort of a function to support the menu item itself. On-click equals something can also be programmed in as well in terms of the attributes for XML code. Same thing we did with the button clicks. We can do the same thing with the menu items in the option menu. You can use an on-click. So generating the menus in the XML, we can actually use we did this actually in the XML code. We can define a menu in the, I think I still have an Android project opened. I do. Out here, if you refresh your memory, in the resource folder, we have a menus. In the layouts, we have menus. Let's see. Not by default, we actually have to add it. We can add a menu subfolder and we can put a menu inside of it. We can also generate the menu programmatically. So we did both of them actually the second weekend. So we've done that before. So part of the review for the final is just remembering, what did we do? But if you go back through and review the notes, maybe it'll jog your memory. In fact, it's actually kind of interesting when you see some of the questions, you go, oh, I remember that. Oh, I remember this. I remember that. All the questions are taken out of all the activities we did in class. So questions, you know, that are kind of, when you see it, you'll recognize it if you've seen it before. If you haven't seen it before because you weren't here or something like that, you're not going to recognize it. So, but it's not a hard exam. It's actually fairly straightforward. So here's starting with an outer menu tab and then working inside. So the menus items are indicated by item. So if you remember, I think we did it with colors and labels of something. I can't remember what the labels were for. We wrote a menu. We did a menu.xml file, and we loaded the menu items. I want to say it was for colors. It may have been for fruit or something, or I don't know, some other theme we did as well. We had two of them. All I'm remembering right now are the colors, but if you go back through some of the projects, you'll see it. Actually, there's one that had icons on the menus as well. That may have been done last weekend, or the last time we had class. So we can associate with an ID, an icon, a title, a clickable radio button, something of that nature. We can also put submenus in there that are defined by menus within an item. So when an item brings up a menu. If you click on this resource here, we'll look at the menus resources that are available. In generating the XML menus, we have a bus menu in this example. This is the XML code. It has lots of items for gold, black, gray, downtown, different types of buses, I guess. And then we have a 3-item menu here with the green. This is the one we did. Green, blue, yellow. So we definitely did colors. And then when we clicked on the menu item, it changed the color of the background of the view, is I think what we did. So, which is where this is coming out of, actually. So triggering menus. When the menu hardware button is pressed, the listener's function is called automatically, which inflates the menu.xml file. So on the create options menu, we can use the menu inflator. This is what we did actually. And we took the menu inflator and we did get menu inflator. And on the r.menu, whatever the menu was called, we returned the information just like we did for the inflator for the main activity XML file. So, alternatively, you can build menus dynamically or directly with Java, calling the menu item constructor. We actually saw both of those done the same way. So, handling the selection items for the menus, we can put them all into one menu, into one action that's going to be performed when the menu is actually selected, and it's going to be on options item selected. The default project actually has it written there for us automatically. I don't believe this one's going to have it because this is made by an older template. So now this is not going to have it, but if we just created a brand new project, we would see that in there. And we actually see a default menu that's being created as well in that particular case. So we can call the super function to go to the super one, and then we check the IDs. Was this one selected? Was that one selected? And then this is the one we did, actually. We had the red, green, and blue, and we select the items, and it changed the background color. That's what we did to it. This is the example that we did. So what I'm doing now is catching up on the textual PowerPoint presentations from all of the examples we did earlier. So, all right, so that's everything you ever wanted to know about the menus. And let me go find my directory again. We want another break, or are we good? Like every hour I'm going for breaks or no breaks. Break or no break?
Yes. Break, yeah.
Small one? 10 minutes again? Okay, good. 10 minutes good.
We have to study about it. Not study that.